Hello everyone. In this video, I will discuss some topics of linear algebra. First, I will start with elementary row operations. Then we will explain what is row echelon form of matrix. And then I will explain what is the rank of matrix by using row echelon form. And lastly, how to find column space of matrix. So if I look at elementary row operations, there are three elementary row operations, and these are: first is you can interchange any two rows of matrix, and second operation is you can multiply any row of matrix by a constant, and third operation, which is very important, is that we can add a constant multiple of any row to any other row. That means, for example, we can add a constant multiple of row 3 to R2. So I'll write R2 plus 2 times R3. That means 2 times of R3 is added to second row. This is very important. Let us see with one of the example here. So here I have taken a matrix A, which is given here. So matrix is 0, 4, 6, 2, 2, 1 and 1, 3, 4. So if I want 1 at this first place, what I have to do, I have to interchange R3 and R1. So apply here R3 interchange by R1. So A will be changed to a new matrix, which is 1, 3, 4, and second row will be unchanged. So 2, 2, 1 and 0, 4, 6. This is how you can write operation 1. Now suppose if I want to make this 2 here 0 by using row 1. So what operation I should apply? I will change second row, that means R2. So I will write R2 minus, if I multiply by 2 and subtract from second row, I will get 0 here. So 2 times R1. So after that, what is the matrix A? This matrix is changed to 1, 3, 4, 0 here, and 2 minus 6 minus 4, and here 1 minus 8 minus 7, and third row will be as it is. So I have 0, 4, 6. Now again, if I want to make this element 0 here, this 4 make to 0. So now I can use first row or second row, but if I use first row, I will have 1 here and it will come here. So I will use second row here for making this 4 as 0. So what operation I should apply? Simply I should write R3 and R3 plus R2. What is resulting matrix? I have here 1, 3, 4, then 0, minus 4 and minus 7, and last row will be 0, and here 0, and here it will be minus 1, right? So this is how you can apply these operations here. Now let us see what is row echelon form of matrix. So it is a special form of matrix by which we can directly tell the rank of matrix, and this is particularly also useful for solving non-homogeneous system or homogeneous system Ax equal to 0. So let us see what are those conditions when we say matrix is in row echelon form. So here, first condition is all 0 rows should be at bottom of the matrix. That means while changing into row echelon form, if any row becomes 0 by elementary operations, we have to immediately write that matrix at bottom by exchanging with some other rows. And second one is very, very important. That is the leading element. Leading element means the first non-zero element of a row is leading element, or it is famously called pivot. Okay. So leading element of any row should be at right place or right side to the leading element of previous row. This you have to keep in mind. That means if I have second row has leading element, the third row leading element should be at right side, not the left side, or not the just below of the leading element in the second row. Let us see some examples. It will be more clear with those examples. So I have taken here example number 1, and let's see what is the matrix A here. So if I write here matrix, so that matrix is, let's say we have 1, 2, 3, 4, and 0, 2, 3, 4. Third row is 0, 0, 6, 0, and last row is 0, 0, 0, 0. So this is the 4 cross 4 matrix. And if I look at here, so to identify whether this given matrix is in echelon form or not, we have to check out leading elements and the condition. So there is 1 0 row which is at the bottom. So first condition automatically satisfies. And now look at the leading element. So first non-zero element in the first row is 1. Second row leading element is 2. Third row leading element is 6 here. And you can easily see in the second row, leading element is right side to the leading element of previous row. In the third row, leading element is at right side to the leading element of previous row. And fourth row has no leading element as it is 0 row. So this is in REF. Okay. This matrix is in REF. Now take another example. Example number 2. And let's take matrix B as a new matrix as 0, 3, 4, 6, 2, and 0, 3, 2, 0, 4, 0, 0, 0, 0, 0, and last row is 0, 0, 0, 3, 4. So this is 4 cross 5 matrix. Now check out both conditions whether this matrix is in REF or not. So I can easily see there is a row, third row, which is 0 row, but it is not at the bottom. So it is not in REF. First condition failed. Okay. Now if I change the matrix by applying R3 and R4, if I change R3 and R4, what I have now, resulting matrix B will be changed to a new matrix 0, 3, 4, 6, 2, 0, 3, 2, 0, 4. And the third row become here the fourth row, that is 0, 0, 0, 3, 4, and last row is 0, 0, 0, 0, 0. Now again look at here. So first condition is okay, 0 row is at the bottom. But now look at the leading element positions. So first row has leading element 3, and second leading element in the second row is just below it, okay, not at the right side. So this matrix is not in echelon form because of this element. So I have to make this 3 0 by using previous row. So what operation I should apply? We have to apply R2. We are making change in R2. So R2, if I subtract here R1, then this will become 0, right? So let us do that operation. and see what is resulting matrix. So B changed to 0, 3, 4, 6, 2 as this. Now 0 and here it become 0 and 2 minus 4 become minus 2 and then 0 minus 6 here and 4 minus 2 is 2 here. Third row is unchanged. So 0, 0, 0, 3, 4. Last row is already 0. So I have nothing to do there. So now this matrix is in echelon form or not? Let us just check. So this is first leading element. Second row has a leading element this. Third leading element in third row. And 0 row is at bottom. So first condition satisfied. Second condition satisfied. And this means the matrix is in echelon form. Row echelon form. Okay. So this is now in echelon form. Row echelon form. Okay. Let us take one more example and I will leave it to you and you just check it whether it is in REF or not. If it is not in REF, just change into REF. So matrix C equal to I am taking here. It is given as 2, 3, 4, 5 and 0, 0, 6, 2. Third row is 0, 2, 0, 3 and fourth row is 0, 0, 0, 0. Now your task is check whether C is in REF or not. If it is not in REF, change it into REF. I hope you understand the concept of row echelon form. It has only two conditions. First is 0 row while applying elementary row operation should be at the bottom and leading element of any row should be at right side to the leading element of previous row. Now let us move to the next concept which is rank of matrix. And rank of matrix is very, very important. So ideally, if I go by Bookie's definition, rank of matrix A is defined as rank of is R here, which is natural number, if there exists largest submatrix of order R, which is non-singular. Non-singular means determinant is non-zero. So by using this shortly, we can write rank of matrix is the largest order submatrix which is non-singular. And that means we have to check out submatrices of a given matrix to find out the non-singular matrices as per the Bookie's definition. So I hope you understand what is the meaning of singular means determinant is 0. Non-singular means determinant is non-zero. So here, let us check out few matrices. So as an example, I will take here. If I have matrix given as A is equal to a matrix, let's say it is 2, 4, 6 and 8, 2, 3, 4, 8, 12. So we can clearly see here that date of A is 0. And this means 3 cross 3. This is 3 cross 3 matrix, which is submatrix itself. So rank should be less than 3, right? Now I need to find out submatrices of order 2 cross 2. So if I take any block of 2 cross 2, let's say take this one. So I have, let's say M22 and this is 2, 3, 8, 12. What is date of this? It is non-zero. No, it is 0. 24 minus 24 is equal to 0. So this is 0 here. So now we cannot say rank of matrix is 2. I need to check another. I need to check another submatrix. And let's say it is the first one, which is here, this one. So this M11 I can write easily. So 2, 4, 8, 2. What is data of this? 4 minus 32, non-zero. It is equal to 28. So non-zero. So I can write rank of A is equal to 2. So you can easily understand this is very, I can say lengthy process. We have to check every submatrix of 2 cross 2 and then data of A also to find out rank of matrix. For example here, if I take another one, example number 2, so you can check out B is equal to a given matrix. This is -1, -2, -3, -3, -6, and -9. And the third row is 2, 4, 6. So you can verify data of B is equal to 0. This implies rank of B is less than 3. Now for rank can be 2 or 1. Okay. So you have to check all submatrices, and for this matrix you can easily see that all submatrices of order 2 cross 2 are singular. So rank of for this all 2 cross 2 submatrices of B are singular. Singular means their det is 0. So this implies what is rank of B? This is 1. Okay. As I said, rank of A, rank of any matrix M cross N belongs to natural number, and that means 1, 2, 3, 4, and so on. Zero matrix is the only whose rank is 0, but there is no point of finding rank of zero matrix. And second note, you can make it as this first note. Second note is rank of matrix M cross N, that means M rows and columns, is equal to, or you can say less or equal to minimum of M comma N. So it will give you an upper bound for the rank. Okay, this provides an upper bounds for the rank. So these 2 points you can note down, and these will help you in identifying the rank easily. So next I can explain how to find rank of matrix by row echelon form. So finding how to find rank of matrix A by REF. So we have already seen REF, row echelon form. First, let us write here the definition by REF. So this is rank of A is number of non-zero rows in row echelon form of matrix A is the rank of matrix. Remember that here matrix A should be changed into row echelon form. Then you have to count number of non-zero rows. Do not count directly how many non-zero rows in matrix A. I'm clearly saying it is REF of A. So by this, you can find out easily rank of matrix, particularly when the matrix is non-square. So for square matrices, you can use the concept of determinant or submatrices. For A, M cross N, you have to use REF. So recommended is REF. So what is this way to find REF? I will explain. Let us now see one example here. So in this one, your matrix A is as matrix A is given as 2, 4, minus 3 and minus 2. Second row is minus 2, minus 3, 2 and minus 5. Third row is 1, 3, minus 2 and 2. So what is the order of matrix? It is 3 cross 4. So by using the previous notes, I can easily write here rank of matrix A 3 cross 4 is less or equal to minimum of 3 comma 4, which is less or equal to 3. So this is upper bound of rank. So that means rank can be 3 or 2 or 1. This implies rank of A can be 3 or 2 or 1. Okay, as it is non-zero matrix. So, but here I will go by procedure and see how to find rank of matrix by elementary row operations. So now change this matrix into row echelon form. And for that, you have to check out first what is leading element in the first row. So it is 2 here. And that means I have to make these two elements 0 so that in the second or third row, leading element should be at right place. So first of all, I will do these by using R1. So what operation I should apply? I can easily write down R2 and in the change is R2 plus R1 and third row for I can write R3 as R3 minus 1 by 2 R1. So after that, your matrix will be changed to a new matrix, which is A as changed to first one change. So 2, 4, minus 3, minus 2. And second row will be 0 here. And then I have minus 3 and plus 4, that is 1 here. And then minus 1 here. And this is now 7. Third row is 0 here and this 3 minus 1 by 2. No, 3 here minus 2 minus 3 by 2. So what I have here is 1 here and this place I have minus 1 by 2 and this is 2 and plus 1, so it is 3. Now whether this is in echelon form, just check it. So here I have leading element and second row have leading element this one, but just third row has leading element this, which is just below it. Okay, so this should not be there. So I have to make this 0 by using second row. So for that I will apply operation R3 plus R2. Okay. So after this, your matrix A will be changed to a new matrix 2, 4, minus 3 and minus 2, 0, 1, minus 1, 7. Last row will be 0, 0. And here it will be like 1 by 2. No, I have to make minus sign here, not like this. This would be minus sign here. R3 minus R2. Okay, so minus sign here. And after that, this last one will be 7, 3 minus, this is 7 minus here, and this is now 10. Okay, so this is now the final matrix, which you can check whether it is in REF or not. So Z, first leading element, second leading element, and third leading element. There is no non-zero, there is no zero row. Okay, so that condition automatically fulfilled. So this implies you can write down what is the rank of matrix. So rank of matrix A is equal to number of non-zero rows in REF. This we have to write always, which is 3. So rank of matrix A is 3. Further, by using this REF, you can simultaneously find what is the column space of matrix A. So let us write what is column space and try to understand it. Column space of matrix A. So actually this column space is the set of columns of A which are independent, and that means you can write as a column space of A is set of columns of original matrix corresponding to pivot element in REF. That means once you have reduced the matrix into row echelon form, you have pivot or leading element like in the above matrix here. So these the pivot columns will form the column space of matrix A, but columns will be the original column of the matrix. So call set of columns of original matrix corresponding to pivot in matrix A. Okay, so here column space of A will be the set of columns, that means C1 which has leading position, C2 also and comma C3 also. Fourth column has no leading element here. Okay, fourth column has no leading element, so it will count only these, and we can write this as what are the original columns. So I can write here 2 minus 2 1, and then second column is 4 minus 3 3, and third column is minus 3 2 and minus 3. And further, if I talk about what is the dimension of column space, so dimension basically is how many elements in that set, and these are independent. So dimension of column space of A is equal to number of elements in set of column space. Okay, column space, and which is 3. So this is how you can find out the column space of a matrix A. Now I will write few examples here. You can try for your practice. So I will write practice problem 1, that you can find out rank of matrix and column space of A, where matrix A is given as 0 1 minus 3 minus 1, and then 1 0 1 1, and then third row is 3 1 0 2, and fourth row is 1 1 minus 2 0. So this is the matrix for which I need to find out column space and rank of matrix. So as it looks a very interesting kind of matrix, and it is of order 4 cross 4. Okay. So not easy to compute the determinant of matrix. So the only best way is you can use row echelon form. So now here I want to solve it, and it's look very interesting as leading element first place is 0 here. So what I should do first? So either I can change R4 and R1, or I can change R2 and R4. No, R2 and R1. So what I will do first, let us change R4 and R1. So what I have here, let us change R4 and R1. Okay, so what will be the new matrix? This I can write now as 1, 1, minus 2, 0, and then 1, 0, 1, 1, 3, 1, 0, 2, and last one is 0, 1, minus 3, minus 1. This is a new matrix after applying operation number 1. Now here I can easily use now this element to make this 0 and this 0. So what I will do? I will do R2, R2 minus R1 and R3 as R3 minus 3 R1. So by applying this operation, your matrix A will be changed to 1, 1, minus 2, 0, and then 0, minus 1, and here I have now 3, and 1 minus 0 is 1, and this is 0, and 1 minus 1 is 0, and then I have here, this is R2 minus R1. So here 3 I have, and then what I have here? No, this is third row. So 3, okay, 3 minus 3 is 0, and then 1 minus 1 is 0, and 0 minus 3 is minus 2. So let us correct it. So here, okay, let us recheck 3 and then 1 minus, okay, 3 times 1 minus 3, okay, minus 2. Yeah, here the mistake, minus 2. Minus 2 and 0 minus 6. So plus 6 here, and then here I have 2. Fourth row is 0, 1, minus 3, minus 1. This is now again not in REF. This is leading element. This one is leading element. So I have to make these two elements 0. So I will again apply one more operation, and that is R3 is now changed to R3 minus 2R2, and R4 is now R4 plus R2. So after this, your matrix A is changed to the new matrix, and which is 1, 1, minus 2, 0, and 0, minus 1, 3, 0. And then I have here 0, 0 here, 0 here, 0 here. Last row 0, and then 0, 3 minus 3, 0, minus 1 plus 1, 0. So this is now the final one, and this is now in echelon form. 0 rows are at the bottoms, and these are two leading elements. Okay, so this means which is in row echelon form, and that means what is the rank of matrix now? Rank of matrix A equal to number of non-zero rows in row echelon form, which is 2. So rank of A is equal to 2. At the same time, now you can write the column space of matrix A. And this implies your column space of A will consist of how many columns? The columns which have pivot element or leading element in REF. So column 1 and column 2 have only the pivot elements. So column space will consist of set of C1 and C2 of original matrix. Okay. And that means I can write now the columns of original matrix as a set form. So 0, 1, 3, 1. And second one is 1, 0, 1, 1. So this is the column space of matrix A. And you can directly write what is dimension of column space is equal to 2. So I hope you understand the column space and rank of matrix and the elementary row operations and row echelon form in this video lecture.